Welcome to section 3.6, this time on the topic of parallel and perpendicular lines. And in this section, what we're really doing is continuing our talk from section 3.5 when we talked about how do we find the equation of a line. This time we need a little bit of an extra help to look for the equations of lines when it comes to parallel and perpendiculars. But as long as you know the definitions, you'll actually okay. And here's the first one. We say that two lines are parallel to one another if their slopes are equal to one another. So what do we say about this one? That means if we have two lines, line 1 and line 2, then as long as slope 1 is equal to slope 2, the two lines will be parallel in the plane. We could certainly draw this out right here so that you see an illustration of parallel lines and kind of get the idea of how that works. Let's see, we'll get rid of that here. And put in a proper line here for you. Okay, so let's say we've got this line number 1 and the line number 2. As long as these two lines are parallel, it would make sense to us that the slopes have to be equal, because any rise over run that we get in line number 1 must be the same as the rise and run in line number 2 for these two lines to be parallel to one another. All right, so let's try this out. Let's say we've got two lines right here, and the first line has the coordinates 2, 1, and 0, 5 in it, and the second one negative 2, 4, and negative 2, 2 in it. Can we determine if they are parallel to one another? Well, certainly. We just compare the slopes. Let's do line number 1. So for slope number 1, we're going to say, let's take our points 2, 1, and 0, 5, and that means our difference in our y values are going to look like this: 5 minus 1 divided by 0 minus 2. So in this case, we're going to get our slope of 4 divided by negative 2, which reduces, as we know, to be negative 2. So this is slope number 1. Let's look at slope number 2. In slope number 2, we're going to take the difference in the y values of our second pair of points. In this case, that is negative 2 from the second value for y, minus 4 for our second value for y value from the first point. And then we're going to take negative 2 as our x value out of the second point right here and subtract negative 2 right here. Well, we get negative 6 in the numerator this time, and we get negative 2. This is the same as negative 2 plus 2. And we know how that one turns out. It's going to be 0, which means that this is actually undefined. So answer the question. Are these two lines parallel to one another? The answer, not parallel. Right? And this is just by looking at the slopes. We didn't even have to draw the lines to get to that conclusion. All right, so let's make it a little bit more of an interesting game. Let's say this time we're told to find the equation of a line that, first of all, contains the point 2, 1, and secondly of all is parallel to the graph of 3x plus y is equal to 1. All right. Whenever you see this description, we're saying you usually see this description, find the equation of a line that contains the point 2, 1. This is not a point on the given line, right? If you put in x equals 2 and y equals 1 right here, you do not get negative 1, right? We just know that this is going to be a point on the line that we want, and that line also has to be parallel. So that means that if we need a slope and a point, to find the slope, we've got the point. To find the slope, solve for y in the given equation. So we've got 3x plus y is equal to negative 1, and we isolate y by adding negative 3x to both sides. So we're going to take negative 3x to the left and negative 3x to the right, and you get y is equal to negative 3x minus 1 as our coordinates, or as our equation. And so, of course, having a good day, we're going to call our slope right here negative 3. All right. This is the slope of the given line. what slope do we need? So we're going to use the slope -3, and that line is going to pass through the point 2, 1. All right, let's set it up here. And I like my point slope formula. Remember, y minus y1 is equal to m times x minus x1, where the y1, the x1, and the m are all fill-in-the-blank values right here from our given information. And so this is going to be y minus 1 is equal to -3 times x minus 2. Right? Now, if we simplify this to put it in the same sort of variable form here, you'll see that we get y minus 1 is equal to -3x. -3 times -2 is plus 6. And we add 1 to both sides, so we get y is equal to -3x plus 7. So this is the equation of the line that is parallel to our original given line. More in the next video.